I'm going to repeat this because I just realized for a minute I did not have the other device recording. So 1a minus 0.11a, combine like terms, 1 minus 0.11, 9, 8, and 0. So here was an equation. We combine like terms. This was an expression to combine like terms. We combined 6.3 minus 3, 3.3, and this operation gives us a negative number, and we subtract 4.5 from 8.7 to get 4.2. So now we have two equations to work on. Negative 15.99 equals x plus 7.14. And the other one, the same idea. And then we'll continue with more equations. How will you determine x? What operation will you perform? What is the idea here? How will you solve for x? It's the same type of equation. How will you solve for x in both situations? What needs to be? Yes.
Subtract the number from the right side?
Yes, both situations. In other words, move this term to the other side and it becomes negative. Negative 15.99 and then minus 7.14. They are both, we're adding them. Remember, decimal points have to line up. Okay. 9 plus 4 is 13, 3, and I carry 1. 10, 1, and I carry 1 again. Copy the decimal point. 5 plus 7 is 12, plus 1 is 13, and I carry 1, so I get 2. So then x equals negative 23.13. Any questions on this? Okay, the same thing with the other one. We have 19.99 and 4.28. We have to add them. Remember, the decimal points have to line up. 7 and I carry a 1. And that's 12 and I carry a 1. And that's 14 and I carry a 1. So then the answer equals negative 24.27. Now I'd like to look at any questions, please? Any questions? Okay. I would like to look at two applications that you will see in your homework. So that's page 7. No, 7, no, 8. So you will see something like a donut in which they're giving us the diameter of the interior. So the diameter here is 1 and 5/16 inches. And they're telling us that this band is 1/8 of an inch. What they're asking us to determine is the big diameter. They want us to find this. Can anyone have an idea? Anyone has an idea on?
1 5/16 plus 2/8.
Yes, perfect. So the entire distance, this distance, is 1/8 plus another 1/8 plus the interior diameter. Excellent. So I'm going to call this x. So then x equals twice 1/8 plus 1 and 5/16. Let's put the integers back. You can simplify here or not for a moment. 1 times 16 is 16. 16 plus 5 is 21/16. So now we're going to have to find the least common denominator, which is the least common denominator is
16.
yes, indeed. What is the adjustment we need for the top of the first fraction?
Multiply by 2.
Very good. 2 times 2 is 4 plus 21. So then x equals 25 over 16. And if we want to take the integers out, it's 1 and 9 over 16 inches. Any questions on this problem? Any questions on this problem? Okay, let's talk a little bit about something called uniform motion. Oh, uniform motion. Uniform motion means constant speed. Well, this is not really possible. I have to get to a certain speed. So from 0, I need time to get to 50 miles an hour. But if I keep the speed at 50 miles per hour, let's say for 1 hour, then I achieved uniform motion, constant speed. But to start at 50 miles per hour is not possible. So I need time, even if it's few seconds, from 0 to 50 miles an hour, and then I can keep it at that rate or speed. Assuming that that's the situation, assuming that we are talking about uniform motion, distance equals rate or speed, same thing, times time. This is the formula for uniform motion when the speed is constant. So let's suppose we are told that the distance is 8 3/4 of a mile. Let's suppose that we are told that the rate is 3.5, and this is measured in miles per hour. And we're asked to find the time. So the equation that we're looking at is 8 3/4 equals 3 1/2 times time t. This is what we want to solve. Remember, we have to put the integers back in to find the time in hours required or needed to cover a distance of 8 3/4 of a mile at my slow speed at 3.5 miles an hour. How do I find the time? But remember, we have to put the integers back in first. Can anyone tell us how to put them back in? What will I get in the first one? What do I get in the second one when I put the integers back in? What about the first one?
35 over 4?
35 over 4. And the other one? Good.
7 over 2?
7 over 2. Good. Now we want to solve for t. What should we do to both sides? Look at the equation, slowly decide what to do.
Times both sides by 2 seconds?
Exactly, brilliant, indeed. It doesn't matter when you put where you put it. This product, because we know product is associative and commutative, this will give us 1, which is t. But I cannot forget to multiply both sides. I will not be solving correctly. I will not be solving anything, actually. Okay, do not multiply. We want to simplify. It's easier to simplify first. By 2, put the 1 so you don't think it's 0, and by 7, and we have 5/2. We really don't like to write it like this. We write t equals 2.5 hours. It's not incorrect to write 5/2 of an hour is t, but we are asked to find t, so t equals. Any questions? Any questions? So, at my slow speed at 3 miles an hour, in order to cover the distance of 8 3/4 miles, I need 2.5 hours. Is this correct? I don't know. But if I multiply this by this, changed into improper fractions, first I have to put the integers back. When I multiply them, I have to get this. If I don't get this, then this is incorrect. Okay, now any questions for me? Any questions? Okay, so let's look at multiplication of decimal numbers. So for example, 14.3 multiplied by 0.4. So remember when we add and subtract decimal numbers, the decimal points have to line up. Not here, not with the multiplication. It happens in this case. So I have 14.3 multiplied by 0.4. So the numbers have to end at the same spot. We don't care whether the decimal point lines up, not for multiplication. So here's how I multiply. 4 times 3 is 12, 2 and I carry 1. 4 times 4 is 16, plus 1 is 17, 7 and I carry 1. 4 times 1 is 4, plus 1 is 5. Here's what I do next, because there is nothing. I will not multiply by 0. That's always 0. Here's what I have to do next. I see 2 decimal digits. At 572, the decimal digit is here. Because I see 2 decimal digits, I have to move the decimal digit from the end of the number 2 spots to the left, 2 spots over. So that the simplified form is 5.72. Any questions? Let's perform more multiplications of decimal numbers. Yes, you can use a calculator, but you need to understand how this works. It's very important. Okay, here's another one. A negative 450 multiplied by negative 0.02. First, we address what?
The sign?
Yes, of course. I want to get rid of that. 2 negative numbers, when I multiply them, I get a positive number. On the side, 450, the numbers have to end at the same spot, 0.02. Notice that the decimal point on 450 follows 0. And we do not line it up with the decimal point from the other one. The numbers, when we multiply, have to end at the same spot. So here's what I do. 2 times 0 is 0. 2 times 5 is 10. 0 and I carry a 1. 2 times 4 is 8. Plus 1 is 9. Like before, I count the decimal digits. How many are they? I see 2. So I move the decimal point from the end of 900 exactly 2 spots over. So the answer is 9. Any questions?
Yes, how did you get 9?
2 times 0 is 0. 2 times 5 is 0, and I carry a 1. 2 times 4 is 8, plus 1 is 9. I count the number of decimal digits, and I move the decimal point exactly 2 spots over.
Okay, thanks.
Is that okay?
Yes.
Perfect. Now, multiplication by 10 or 100 or 1,000 is always very easy of decimal numbers. So 25.5 times 10, all I have to do is move the decimal point 1 spot because I have 1 0. So it's 255. That's always easy. If I have 25.5 multiplied by 100, I have to move the decimal point to the right 2 spots. So 2550. And so on and so forth. Multiplication by powers of 10, we say. Always easy. Okay, this was a 10, this was 100. Now, in the other direction, if I have negative 796,000 and I want to multiply by 0.01, well, I know what 0.01 means. It's 1 over 100. 2 decimal digits, 2 zeros. What does this mean? Well, 2 zeros will cancel 2 zeros from here. That's all it does. And I have negative 7960. Any questions? Any questions? Okay. What about 82 multiplied by 0.001? Well, this is 1 over 1,000. 1, 2, 3 digits. 1, 2, 3 zeros. Well, what will division by 1,000 do? We'll move the decimal point 3 spots over, 0.082. So when I multiply by 10, I move the decimal digit correspondingly to the right. Well, when I divide by 100, I move it this way 2 spots, or this way 3 spots. So when I multiply by 10 or 100 or 1,000, I increase the number. But when I divide this number by 100, I diminish it a lot. When I divide this number by 1,000, I diminish it a lot. From $82, now I have 8.2 cents. Here, when I multiply by powers of 10, positive powers of 10, 10 or 100, I increase the number from $25 to $255, from $25 to $2,500. But when I divide by 100, I diminish the number. When I divide by 1,000, I further diminish the number. Any questions? Let's simplify. We do not want decimal numbers in a fraction. In general, no decimal numbers in a fraction. No decimal numbers in a fraction. What does this mean? No decimal numbers in a fraction. Okay, let's take a look. So 0.156 divided by 4. We're asked to present it in lowest terms. And no decimal numbers in the final answer. Okay, so here's what I'm going to do first. I see 3 decimal digits. I'm allowed to multiply by the top, by to multiply the top and the bottom by the same quantity. Why will I choose 1,000? Because 1,000 has 3 zeros and this number has 3 decimal digits. What if it had just 0.15? I would have multiplied top and bottom by 100. What if it had just 0.1? I would have multiplied top and bottom just by 10. But this number has to be the same. I cannot multiply, oh, you know what, I want to multiply the top by 1,000 and the denominator by 10. No, I'm changing the problem. If I choose, and I have to choose 1,000 because of 3 decimal digits, if I choose 1,000 for the top, I have to multiply the bottom by the same thing. Okay, so what do I get? I get 156 over 4,000. So first of all, I eliminated the fraction. I'm sorry, the decimal number inside the fraction. Now I see they're both even numbers, so I have work to do. I'll simplify the denominator by 2, and I'll simplify the numerator by 2. 78. So now I have 78 over 2,000. I see again that they are even numbers. Fine. I'll simplify by 2. I'll get 39. I'll simplify by 2, and I get 1,000. And this is it. Just 39 over 1,000. Or if they want me to go back to a decimal number, I can. I'm dividing by 1,000, so the decimal point is here. How many spots will I go to the left? How many digits will I move the decimal point?
Three.
Yes, because I count 3 zeros. 1, 2, and a 0. Exactly. Let's work on negative 30.15 over 0.3. 1 minute.